Okay, let's try this graphing question. They want us to graph f of x equals cos 3x and g of x equals cos x all on the same graph, but between minus 90 degrees and 120 degrees. Now, let's just take a look at this. You'd go at minus 90 degrees and 0 degrees. You have to know that cos of 0 degrees is 1. And then it's a wave, just like a sine wave, the cos wave. The step here is 90 degrees, and then 90 degrees later it goes back to 0. And on the left-hand side, it's at 1. It goes to 0 there too. So if you're sketching this graph, and you're going to be given a graph thing like this between 120, you know it's 0 and 1. You know it's 0, minus 90 and 0. And you know it's 90 and 0 because that's the basic cosine graph. And you can put in every 90 degrees. It goes to a significant place from 1 to 0 to minus 1. But at 120 degrees, put it in there. The cosine of 120 degrees is negative a half. That's the coordinates of that endpoint. Well, there's your function g, the basic cosine graph. Now for the cos of 3x, this 3, you have to know that the period, what it takes to go through a complete wave here, instead of being 360 degrees, it's 360 divided by 3. The period's 120 degrees to go through a complete wave. And the step, instead of 90 degrees, is 90 divided by 3. Now, I don't need a calculator, and it's much easier. I know that cosine, the cosine of 0, if I put in 0, it's 1. But then if I move 30 degrees, because that's the step, 90 divided by 3, if I move 30 degrees, I go back to 0. Another 30 down to minus 1. I got to label that. Then 90 back to 0. Then 120 up to 1. And you got to label that. Now at 0 and 1, negative 30 degrees goes down to 0. Then to minus 60 and minus 1, and back to 90 degrees and 0. Don't have to label that because it's already labeled if you have these angles labeled. Well, there's the sketch of the whole thing. Cosine goes through, it should go through a complete wave on 120. Let's see. There's one way, air, it's 120 degrees. In fact, from 1 to 1 there, a complete wave in 120 degrees. I must have graphed it right. Now, how do we do this? F of x minus g of x is greater than 0. Well, where is that true? Well, it's much easier to think of as just to add g of x and to think, where is f greater than g? Where does the red go above the green? Well, it only happens here. It does equal 0 here, so we have to consider minus 90 and 1. Or sorry, minus 90 and 0 degrees. They are equal to each other, but the only place where it goes, the red goes above the green, where it's greater, where the f is greater than g, is between 120 and 90 degrees. So that's your complete solution there. Now the next question says, where does f multiply by g to give you a negative answer? Well, that's saying, another way of saying, where is g and f on opposite sides of the line? Well, let's see here. They're on opposite sides here. They'd multiply to equal a negative. So one place is between 120 and greater than 90 degrees. It'd be a negative answer. So there's one little region. Where's another region? Well, let's see here. Oh, between 90. Doesn't work there. It equals 0. But between 90 and 30 degrees, they're on opposite sides of the line. So that's another region where it's true that the green multiplied by the red function would give you a negative number. But here they're on the same. That'd be two positives. It wouldn't work here. The next place it works is in between minus 30 degrees and minus 90, but not equal to it because we want it to be negative, so we don't want it equal to 0. So I figure there's 3 regions. There might be another way of writing that, but I'm pretty sure that's the answer.